Hi, I'm going to do a little bit of explanation because a lot of confusion and people asking why our digital meter, smart meter, our cost of electricity went so much higher than the old meter, and people are fighting to keep the old meters, and there's a battle out there. Uh, it's just a lack of information on both parties. I mean, some people, they like to keep the old meter, because they don't want the power to go up, and the power company, they're fighting, see if they can force people to accept their meter. And anyway, we all know the story. There's just a constant battles of, oh no, you don't know what you're talking, or why is that, and why is that, and there's no answer to it. Well, I got two analog old meter. One here was in pretty good condition, and it's going to be a test later on. Right now I'm going to explain how it works, and then after that I'm going to make another video and do the testing with two analog meter. I will take the power directly from the wall where my clothes dryer is plugged in. I'm going to run the two, line number one, line number two, and through the meter, and the neutral will be run through another meter. So I will be able to see exactly what is going into the dryer and what's coming out of the dryer. If anything's coming out more than a fraction of a kilowatt, then our kilowatt is going back to our door, and we'll find out exactly. When I did the first test, I put my clamp meter. We'll find out if my clamp meter was reading right or wrong at that point in time, because now I'm not using electronics. I'm using good old-fashioned analog, which is about 100 and some years old. Now, first thing we have is the plate, the base plate, which is where the meter connected into the box, right? So we have line 1, or X1, and X2. Your X3 is not connected to the meter. It's the neutral line, the white line, who goes between and get connected directly with your panel, your breaker panel. And then the guts of the meter are screwed to that plate, and they're tied up to X2 and X1. At that point in time, that's fairly clear. We know how it gets into the meter from here to there. And leg one comes here from the top and goes out the bottom. Leg 2 comes up to the top, goes out in the bottom. So now we establish line 2 and line 1 and line 2 are your power line going up, 120 volt each. Okay, goes in, and then your function is connected with a large wire going through, which I was going to show you in a second, and it goes through from that point in time. It's crisscross reverse, but the output always connected the right way. So now that's the back plate of the back of this meter, which is connected to a series of four clamp, and that's how your meter is connected. Power goes in, power goes out, right through the meter. So now we established that this is an analog meter, which I didn't open. The seal is still on. I didn't break it open, so I don't want to play with it. I'm going to use this one as another one to return the bottom one. So that's going to be done in another video, but right now I'm going to explain how that works. So we'll put that meter so people can see it. That's how you push it inside a meter box. And you have a meter in your meter box. Okay. Now, what make this thing click, and why the old bill, hydro bill, used to be said this charge is for single phase service. Single phase mean one wire service, not two, not three, because then they would have to call that two phase. Why we don't hear the word two phase in our electrical world? It's either single phase or three phase. Never two phase, because that's where the little, they can hide their little lies and stuff like this. So now I'm going to explain a little bit more about how a meter works. Here we go. This is an aluminum plate on a little shaft with one single ball bearing sit on it and a needle point on the top of it to establish so it spins freely, right? Now that little shaft have a gear which attached to a whole bunch of, just like a clock. So when that turn, it start moving all the little gears inside and a whole pack of gear here, and the rotation be calculated, and here, and all those little numbers would tell you your kilowatt per hours, how many kilowatt per hours you have. Now, it's all been done mechanically at that point in time here, but what makes this little this little wheel turn, which is totally aluminum and there's no other drive, is an electromagnetic field spinning. And the electromagnetic field spinning, people say, well, it doesn't, aluminum is not what do we call that, conductive for electromagnetic field, right? Because it's a non-ferrous metal. But that's only if you know one type of electromagnetic field. Now, an electromagnetic field deflect of aluminum, instead the plate absorbing it, it became a deflector. So if you have an electromagnetic field spinning that way, it would make the wheel spin that way. If you had an electromagnetic field spinning that way on the top of it, because they put, see all those little dots? I hope you see that, but it's got a whole bunch of little dots imprinted on both sides of this plate. This is for the friction of the electromagnetic field to grab to it. So it actually is just like a tire with tread, right? So you put tread on so you get more grab. Well, this is exactly what that little wheel is. So the electromagnetic field can grab into those little groove and move this wheel around. So you need, electromagnetic field, a vortex creating on top of an aluminum wheel, and you will have this wheel spinning. And this is exactly what Tesla was saying about aluminum. You can use aluminum. In those days, aluminum was terrible and didn't have much of it. So that's how that little thing, or the whole mechanical calculation of a kilowatt, how many revolution per hours will make 1 kilowatt, will make whatever kilowatt it is. Faster the current goes through, stronger the wheel is, stronger the electromagnetic vortex is, faster that wheel will go. Now, let's go to the other parts, who sits behind this little thing who actually make this thing work. There, that's what this bolt together, and that little wheel goes between, and they get bolted together. And by doing so, it create, and this is a coil, an iron, so you create an electromagnetic field. Now this electromagnetic field is compensated by a coil, and this coil here is hooked up to 120 one side and 120 on the other side. So it's actually a 220, a 240 coil. And with the oscillation, this coil creates an electromagnetic field into the iron. And then therefore, the electromagnetic field that one is always the same. It's always balanced on the top, and it's split in two with some copper plate doing a cutoff. Now, the legs, where I was telling you where the power comes in, comes from here. Now you see why they put the tied up this coil from here, so it cannot be affected from the draw. Sorry, I was off the thing. The power goes in. You can see why the little coil is tied up from the beginning of the entry of your power, not on the exit of the meter, so it cannot be affected. So that's have to have a constant electromagnetic field, so we have one base of calculation. Now, on the second side of the field, that bar keep going. Let's create a different field. Now, to make those field up or down, the intake is a heavy wire will go across the other side, wrap twice around, and then come back and come back the coil from this side is on the opposite side. The coil from this side is on the other side. So it gives you an alternative current, and it makes the spinner goes a different ways. Now when the draws, when you're powering, your power comes here, you're powering power and you're using only one leg on 120, right? The calculation of the impedance between for making that little wheel spin only so strong. So it will just make the thing spin at a certain speed, so you get calculated in so many kilowatt per hours. If you hook up something on a both side, it makes the impedance with a double fill, because now you're putting a draw on the second legs, you carry a double fill, and it makes the wheel spin a little faster when you have the draws. But the calculation is always on a even base from that coil here. Now the smart meter, which I call them, this is pretty damn smart actually. And then you had, let's back up a little bit. Then we have what you have in your bill when you get an analog meter that's how it works, right? And if there's anybody can explain it differently or better than me, please take my place, because it's a tough one, because I didn't design this thing. I'm just trying to figure it out. So anyway, now we have how an analog meter is. Now an analog meter only calculated, because since this draw is equal and this field is constant, and you're only changing the field here, and only the strongest field will have the fastest spinner. So it trumped the second field. So it doesn't matter how much pull you add on one side or both sides, wherever the draw is, the little wheel can only spin as fast as the vortex spin. If the vortex spin on a certain thing, a certain speed, and you put another load on that one, but the load is less than this one, it's only going to spin. It doesn't matter if the load come up even. It still spins the same RPM. It's no difference. But if the load increase from one to the other, then it will spin a little faster, because now the vortex spin faster and rub against that little aluminum wheels. So that's how a analog meter works. And that one I don't think is any mystery, because I can take that to any engineer and they can explain that. They might use different words, but the bottom line is that's how it works. Now, what's happening when you receive your bill with the new meter? The new meter is smart, because as we know, we can draw from the bottom, right? And this meter only calculates the highest draw. It doesn't add the two draw together. It's not an add. They don't do an addition. They only give you the highest draw, whatever it works, right? So you always have, because you get charged for one line, single phase. The new meter, the smart meter, charges you for two phase, because what they do, they read the draws on both lines coming out of your meter, because the electrical company says, I don't care if it's a single wire going to the transformer pole, we're going to charge them for two, because they're receiving two wire in their house with power on it. So now let's charge them for two. So each side, doesn't matter which way you're drawing, is calculated on a total on the hourly. So instead it says one wire is drawing 5 kilowatt hours, and this wire is drawing 1 kilowatt hours. Since 5 trump 1, you should be charging only for 5. But now the new meter, if you draw 5 kilowatt per hour on one side and you draw 1 kilowatt on that side, now in the end of the hour that kilowatt get added to the 5 kilowatt. So you got 6. Or if you have 4 kilowatt, 5 kilowatt, now that 4 is adding to 5. Now there's 9 kilowatt. Can you see the bill going up now? Does you see the money clinking, like the registered cash, just like pin flog, money, ka-ching, 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 And that's how it works. Now, I challenge any of corporation who designed those meter, the company who designed the meter, the smart meter, and the analog meter, to come and meet me in the front of a camera and to re-explain how the meter works, how they rip people off. Because this is the biggest lawsuit in North America. They all do it. They've been ripping you off. Soon they change your meter. Bad enough they're ripping you off for the price they're charging you by the kilowatt hour. But now they double the money. We're not, oh, but it says, we own the transformer, we can charge you that. Well, at some point, I got kind of agree with that if they own the transformer. But most people, when you, in most places rural, you have to pay for, you buy your own transformer. They charge you, any hydro company will charge you, 25 years ago it was $1,100 when I put a transformer up. You pay for the transformer, and they keep the transformer, and then you sign a contract with them saying they're going to, if the transformer blow up, they come and replace for nothing. But that contract is literally giving the full power right of your ownership you have. Never sign off, if you own a transformer, never sign off the maintenance of the transformer, because this contract carry a lot more than what you signed for. But if you're on a farm, or you're in a business, a corporation, you have your own transformer, they should only charge you for whatever they give you coming up from the pole into your transformer on one line, because your transformer is the one who gave you the second line. The way it's designed inside, it doesn't take any more or any less, beside being calculated with the analog is the most accurate calculation of power draw. Because the second one, the transformer does that, not BC Hydro or any hydro company. The transformer is the magic box. It's a high, high voltage impulse, or if you want to like, DC impulse is also be called microwave. So microwave can be sent airways or with a line. It follows the line like a train on its track. And it's really, really, really fast. That's what, electricity is, on the power line is instant. So this transmission, which is impulse, DC, not EC, DC, impulse means a period of time on, a period of time off. Same amount of time. Period of time on, period of time off. That's impulse, not pulse. Like most electronic guru, they say, oh, you can do pulse, impulse with electronic. You can't. It's called pulse, and it's just a shorter version of a square wave, but they're all tied up together. Impulse is not tied up together. Impulse, you have a ground line, as you have a ground line on your power pole, and the top line is impulse. High voltage DC impulse. In other words, microwave. So, and then they goes into your transformer on a high volt end, either 14,004 or 7,002, whatever. The outside, the high power line goes on outside of your winding of your transformer and end. The end of the wire is not tied up to anything, not touching anything. It ends, period. Then it goes through layers of insulation. Then you have another wire, that would be your X1. And that's not a wire. Well, some use flat wire, some use aluminum plate, some use copper plate. It's all different version and what designed the transformer. But the one I know, they're aluminum plate and copper plate and flat wires. The flat wires doesn't work as well as the plate. The plate is much better, and the aluminum plate is much, much better, because you get a better bang with the aluminum, because aluminum do not absorb the energy, it reflects their energy. So the transformer itself is not a pig, it's not eating energy and costing you money, or costing the company money, so it's more efficient. So now that's X1, it's a plate of aluminum wrapped around, 3 or 4 turn, taped together, 1 bar comes out and create your X1. That's behind a 1/4 of an inch of I believe is a silicon based insulator. It's like fiberglass with a resin and whatever, and that's an insulator between all those wrapping and stuff. So you have your high power going out on the outside, wire goes nowhere, it just goes down to the end of winding and stop. Then you have insulation, then you have that plate wrapped up, it stopped, and you got a bar coming up, and that creates your connection for your X1. Then you have insulation again, then you have another wrapping of aluminum, just like the first one, and then it stopped, and then you got a second bar, and that will be your X2. And then you have insulation again, and you have more wrapping of that aluminum plate, a third one, and that will be your X3, which is exactly your neutral. And that one is hooked up to the single, and one wire will be hooked up to the can on the end of that plate. Or the plate is not the end of the plate, but the same bar will go to your X1, also hook up to the frame of your box, of your transformer container, and that's grounded to the ground and stuff like this. So that's what make the transfer, and it's wireless transfer at that point in time, because you have to have a jump going through insulation, and there's no wire connected to the other plate, so it's all done in radio frequency transfer, microwave frequency, going through the insulation and bouncing and going through the plate and bouncing and going through the plate. Each plate will bring the voltage, the high voltage down, because it's a mass, not a wire, the length of a wire anymore. It's a solid mass, it's square inches of displacement, which bring the voltage down to 120 for X1, 120 for X2. So this is very simple calculation at that point in time, and how it works. It's literally, it's a transmitting antenna over 3 receiving antenna inside. One is ground, one of the antenna is ground, and it's from the beginning to the middle. You have your high output antenna, transmitting antenna, and you have in the middle, on the tightest core, it will be your ground neutral. That means you have to have wireless communication going through the other X1 and X2, and that's what the volt get trapped and change, converted to 120 volt. The size of the plate, the square inches, the thickness is all calculated to give you 120 volts. Now, that's how this X2 is made. So when you energize the 2 legs out of your transformer, it doesn't really take any more from the pole. The pole is only giving you a frequency with resonance. That's all the pole does. High frequency with resonance. And then this resonance gets eaten through, going through the plates and to the ground. Now, if you own your transformer, you would have a very good chance to fight that one. If you own your own transformer, they can only charge you for single phase. Now, what my question is why they remove the wording on the top of your bill, you know, this service is for single phase only, not 3-phase. Why they don't say this service is for 2-phase on a new bill, since they charge you for 2-phase with a smart meter, right? I don't have a smart meter. It's very hard to put your hand on it so far, and you know, down the road I probably will. But it's a lot of questions being raised. You know, why the hydro? And now we're not talking about a couple of 100 people. We're talking about millions of people in Canada, and company where their hydro bill just went through the roof, so they changed the meter. So I mean, like, you know, people say, oh, this conspiracy thing. Well, you know what? You get your head shoved way up your ass, and the little light you're seeing is not the outside light, believe me, because there's no way out where you're at now. You have to pull your head out of your ass and start looking around. I mean, and listening to everybody else, because everybody is in the same boat at that point. If you have an hydro bill, you're being overcharged, and dramatically overcharged. It could be up to 40%, 30%, all the way up to 60%. You know, people, they said they have tripled their bills you know. And now again, this is electromagnetic field from the pole at what you're bringing into the meter through the transformer, and those electromagnetic field affect digital. And I can show you, you know, how bad is an effect of digital. You can take a normal active radiation Geiger counter and you go to a strong electromagnetic field and that thing just screams like you're going to die tomorrow. There's no radiation there. You know, it's not an active radiation, it's an electromagnetic radiation, like the same one comes out the power line. Electromagnetic radiation, not active radiation. That's another thing, another subject we should get in, you know, to show the difference. Active radiation is plutonium, uranium. Those is active. They're gamma ray, X-ray frequency. The non-active radiation is from electromagnetic pulse or magnetic pulse, magnetic frequency. And that's another type of radiation which is not really harmful unless, you know, you bathe in it 24/7 and on a higher volume. Because look at the guy, for example, when they inspect the power line, well, they cannot turn the main line, you know, millions of volts and turn down whole city for the guy to check the cable. And it cannot be visually checked, you know, they literally have to physically feel and check very closely if there's any crack on that metal in case that cable is going to snap, so they have to replace it. And when they find a crack, they record the position of that cable and they mark with a ribbon on it or a marker, this cable is damaged, so that part of that power line have to be taken down and then replaced. But it doesn't kill the guy. You know, same thing like the bird when he lay on the line. They don't get killed. I mean, the bloody crow get a kill when he go on a transformer, and then they flap their wings and they're hanging out between a ground item like a pole or the gussets who hold the insulator, which is grounded to the pole. And now he's holding the power, and his wind touched the wind pole, which is conductive to a certain degrees. Boom! That bird is dead because he created a contact. He brought the microwave conduction to the earth ground, and this is really, really bad. I mean, literally, really bad. You can tell every lineman was been injured because of that, who killed, and the family, you know, they lost member and stuff like this, and people lost their arm, burn half of their body, most die. It's not nice. It's microwave and it's extremely high potential. So about next video, which I'm going to do is put another meter, and I'm going to connect that to my dryer and turn my dryer on, and we'll be able to record the amount of kilowatt is pulling, and if there's anything coming out with any potential. Now I'm not saying it's going to do it. I'm saying if it's going to come out with any potential, it should make the second one turn also on the neutral line. If it that turn on the neutral line, for that little wheels spin the same or even slower, but it even slightly turn, we have kilowatt going back to the factory. And at that point in time, then they can argue all they want, but I will have solid fact on that one. So I hope that kind of clarified a little bit about all this, you know, how it works. Not too many people saw the inside of an analog meter. That's my first time. Someone gave me 2-ohm meter, and I was so happy. It was like the best Christmas present I had before Christmas. And I've been dying to take those things apart and look at, because that's what I do. I love taking this thing apart, anything apart, so I can learn how they tick and how they function. Because you go and find the book who explain how that worked today. I would waste probably 4 or 5 years to really find something who actually tell me the truth. If there's anything out there, same thing, how everything works on a calculation. It's all about rotation, ratio, you know, and the strength of the vortex or the draws. It will create a vortex, you know, the faster vortex. But that's what makes this little aluminum plate spin. It's not It's not the magnetic field, it's the vortex you create and the magnetic field will brush against that little thing on both sides of that little disc. And you have a left turn and a right turn, and it makes the little wheel goes around. It's just like almost taking an air hose and making the thing turn. Because if I had to put an air hose there, I think I would get this thing turning, because I can just brush it against the air, brushing against that, and it would make that turn. So that's how it works, and I'm happy to demonstrate that to people, on the sample way. And then my next video with that will be tied up to that one here. It will be the one with the dryer, so I can literally tell you then, yes, I mean, we are getting ripped off from the beginning with the digital meters, because they charge you for 2 lines they should not. The second way is, are we returning wattage back to the factory? And if we do return wattage in the factory, why are we not compensate for the wattage we're returning to the factory? Just like you're returning your bottle, you get your 5 cents back. How come we're not getting our 5 cents back per kilowatt? Right? So I mean, like, they're just fair question, right? And every fair question deserves a fair analysis on how it works and if it's true or not. So hopefully that little video will help you, and then when I make the other one, I will add that to that video. So in the meantime, keep your finger crossed, and I will make the other video, and we'll all know at that point in time where we stand with BC or any power company around the world with they charge you arm and legs for powers. So in the meantime, stay safe, dodge the bullets, bob and weave, do whatever you want. Just stay healthy. Catch you later. That's where I like to thanks to say a big thank you to literally everybody who helps me. And when I mean everybody who helps me, I include everybody, the people who support me money-wise, and we know that one person is doing it, and I had a couple of people who did help me, in the beginning. I want to say a very big thank you. I won't mention any name because they don't like their name mentioned, but they will recognize themselves. One person is in Australia, one person is in Toronto, and a few other little people around here. They kind of help me out with stuff, and even sending me and giving me instrument tools, finding stuff for me in the internet and whatever. And also the people who help me is the people who actually believe what I'm doing for what I'm doing it for. This is probably one of the biggest help I have, is having somebody behind me who actually believe it is a better way to make to produce energy, and a cheaper way for people to actually around the world to be able to afford it. And if it's not for all those peoples and to support what I'm doing, and to say yes, and of course we have the odd one in the group, and they think I should be pretty much put in an institution. I'm not, but beside that, it doesn't slow me down when I hear those people, when I know I got so many people behind me who help me out and believe in what I'm doing, and they can't wait to get this thing done and to be able to use it. So for everybody, a big thank you to the bottom of my heart, and hopefully I'll be able to finish this off, and I won't be stopping to do this till I'm totally finished, unless someone drive over me with a 5-ton truck. So at that point in time, you can rest assured I'm not giving up on anything. I'm very close. We're very, really close of breaking the whole thing up. Tesla is no longer a mystery to me. Actually, I can walk a step foot one by one and explain everything what Tesla was doing. So, and I can prove everything out. So at that point in time, people just have a little bit more patience. And again, thank you, and thank you very much for all the people who helped me and keeping my head above water so I can do this research. It's great. It's the best work I ever done in my life. Even when I'm working 24/7 now, instead of working 4 or 5 days a week, But I love it. It's something, it's in my blood right now, and I'm curious to see more and more and more every day, and to learn more about everything. So thank you again. It's well appreciated in my heart.